Good morning. Yes. So, in today's class, we are going to teach you about the switching. What is and switching techniques in computer networks. So, in this class, we are going to knowing about what is switching and what is the switching techniques in the computer networks. So, in general, what is the meaning of switching? So when we have the more number of ways, so we are going to switching to one way to reach the best, to reach the destination, to reach the result in a best manner. And similar to that, so the switching technique in the computer networks also will do the same thing. So in the computer networks, what we are going to doing, we are going to be transmitting the data from one place to another place. So what's the switching technique is? Yes, what is the switching in the computer network is? So it is going to helping the it helps in deciding the best route for transmitting the data from sender to the receiver, so here it is the switching in computer networks helps in deciding the best route for data transmission. So if there are the multiple paths in a larger network. To choose the best route, the switching well helps in deciding the path, and also it is going to providing the connection in between the sender to the receiver, that is one-to-one connection. So the switching technique will implement in the three various methods in the computer networks. The three various methods are in the switching techniques are the circuit switching, message switching, and packet switching. This switching technique will implement in a three methods, so three techniques, and the three techniques are the circuit switching, message switching, and packet switching. So the packet switching again divided, so it can be implemented in the two methods. One is the datagram approach, and the another one is the virtual circuit approach. So now first we are going with the circuit switching. So what's this circuit switching is? Here the circuit switching, the circuit means here there is a circuit, there is a dedicated path like that. So in the circuit switching, how the data is transmitted between the sender and receiver is, so before going to be transmitting the data, it is going to be choosing the path how it wants to transmit the data. So the circuit switching is going to providing a dedicated path, it is going to be establishing between the sender and receiver. So before data transmission only, the connection is going to be establishing in between the sender and receiver. So example for the circuit switching is the telephone network. Yes, in this telephone network, whenever we want to calls to another one, so then first we are going to giving the number, dialing the number, then the dialing the number will connecting the both the sender and receiver. After then it is going to be transmitting the data. After then whenever we are switch off that phone, so then it will terminates that connection. So the best example for the circuit switching is the telephone network. And so here in the circuit switching, it can be how it is going to be transmitting is in the three phases. First, what it is going to be doing is it is going to be establishing the connection. After that, it is going to be transmitting the data. After that, the connection disconnection. The three phases in the circuit switching are the connection establishment, data transfer, and the connection disconnection. So how it is going to be transmitting the data, how it is going to be establishing, I will show you on the next slide. So for example, this is the network. In this network, here I am going to choosing this as a sender, and this one is the receiver. So they wants to transmit the data from here to here. So in this circuit switching, what it is going to be doing is first it is going to be establishing the connection between the sender to receiver. So how it is going to be? Yes, so this is the first connection establishment. Here it is going to be first set up the that is establishing the connection between the sender and receiver. In this way first, so it is going to be choosing the path how it wants to transmit the data. Here it is choosing the route from all the ways. Here it has the various ways, here from here to here, here to here. So it may transmit the data like here and here and here. So but it is going to choosing only one way, that is first it is going to be choosing one way and establishing the connection between the sender and receiver. After that, what it is going to doing is it is going to be transmitting the data. So whenever it wants to transmit the data, it is going to be traveling. So here it is the data. So it is going to be traveling in this way. After that, what is the next phase? It is the connection disconnection. So after when the data is reached to the receiver, the connection is going to be disconnecting. So here it is the connection disconnection. So after that, it is going to be removing the connection in between the sender and receiver. This path will used for another data transmission also again. So here there is a drawback. Whenever the connection is established in between the sender and the receiver, it can't be used for the another transmission, but it is the dedicated path to transmit the data. There is no data loss and there is no network issues. So here it is going to be directly transmitted. Dedicated path is available in the circuit switching. And another switching technique is message switching. So it is another implementation of the switching technique. So another method is message switching. So what it is the it is going to be following the methodology that is store and forward mechanism. So what is the store and forward mechanism is, here in this message switching technique, what it is, how it is going to be transmitting is, here it is going to be taking all the data as the one unit. It is going to be taking all the message as a one unit and it is going to be transmitting whenever it wants to transmit the data. So here in between the sender and receiver, we have the various intermediate nodes. So at that intermediate nodes, it is going to be storing all the data, and then so the intermediate node going to be storing all the data. After receives all the data only, it is going to be transmitting the data to the next node. That is the store and forward mechanism here. So here it is going to be getting all the data, after that only it is going to be transmitting. So it is not suitable for some applications like the real-time applications and for the streaming media. So it is not suitable for that. So what is this is, so it is a store and forward mechanism. So message transferred as a complete unit and forwarded using store and forward mechanism at the intermediate node, and it is not suited for the streaming media and the real-time applications. It is not suitable for that. So how it is, so I will show you this here in this network. So this is the sender and this is the receiver. So it is going to choose it is coming from here, so here to here. So then first this router is going to be storing all the data and then it is going to be transmitted to here. So again it is going to first it is going to be storing all the data and then going to be transmitted. So here at this node also it is going to be storing all the data and transmits, storing all the data and transmit. So in this way the data is transmitted in the message switching technique. So it is going to be following the store and forward technique. It is not suitable for the streaming media and it is also not suitable for the real-time applications. And now we are going for the last one, that is the packet switching. What is this packet switching? So in this switching technique, how it is going to be transmitted the data in the sender and receiver. So here the internet is going to be, it is a packet switched network in the internet. So we are following this packet switched in network. So what is this packet switched network, how it is going to be transmitting the data in the internet? So here first what it is going to be doing is, so here it is going to be in this switching technique, first the message is divided, so breaks the data into individual chunks. These chunks are going to be called as the packets. It is going to be divides the message as the packets and then these packets are going to be transmitted, and for this packet is going to having a number. That number is going to be called as the sequence number. So for to know about the packet, so how many packets in that message, and for the arrange of the data, so we need some sequence numbers. These packets are with the sequence number. Each packet is, so in this packet switching it is going to be sending the data, each packet individually. So the message is divided into the packets, and these packets are going to be sent going to be transmitted individually, not at a whole. So each packet is going to be treated as a one message, and then it is going to be transmitting. So here for this packet, for each packet is also going to be having the source and destination IP address with the sequence number, each packet, and the sequence number will help the receiver. So why we need the sequence number? What is the use of with this sequence number is? So I will show you how it will help in the at the receiver in the in the next slides also. So please remember this. So it is to reorder the packets. To reorder the packets at the receiver side, we need the sequence number. So to reorder the packets, so why means, so here each packet is going to be transmitted individually. So in that, so for example, so we break down the message into four packets, 1, 2, 3 and 4. So the one is transmitted in one route, another route, the second one packet is transmitted in another way. So we transmitted the packets individually. So when we transmitted, the second packet reached first. After that, the first packet is reached. So the receiver doesn't understand what is this, what is this. So to know the sequence of that packets, so it requires the sequence number. So that is so it reads it needs a sequence number. That is to reorder the packets, we have the sequence number. And also the receiver, so it is not the overall message, we are going to sending the individual packets. So due to some network issues, we may lose the data. The receiver don't know about that when we don't have the sequence number. So for example, in the four packets, 1, 2, 4 are reached to the destination, it doesn't reach the third packet. So the destination will know, the receiver will know about, so I didn't receive the third packet. So the receiver will request the sender about for the third packet. Whenever we have the sequence number, it is possible. So to detect the missing packets, we require this sequence number. And to send the acknowledgement, so I received the first packet, please send me the second. So like that also. So I received all this data, I received all these packets. The first sequence number I received, the second packet number I received. So to know the sender about what packets are transmitted perfectly to the receiver, so we need this. Yes, for this, what is this packet switching is? The internet is a packet switched network. Message is broken into the individual chunks called as the packets. Each packet is sent individually, and each packet will have the source and destination IP address with the sequence number. What is the requirement of the sequence number is to reorder the packets, to detect the missing packets and send the acknowledgement. And this packet switching will implement in the two approaches. Those are virtual circuit approach and the datagram approach. How it is in the virtual circuit approach? Yes. So in the virtual circuit approach, what it is, we know that what is a circuit switching technique. What it is here, in that circuit switching technique, it has the dedicated path. So similar to that, in the packet switching also, it is going to be maintaining the connection oriented. So it is also a connection oriented. It is a virtual circuit. Why? Because it is going to be establishing the connection logically. It is going to be establishing the connection logically. So the virtual circuit switching is also known as the circuit connection oriented switching. So in this case, the virtual circuit switching, a pre-planned route is established before the messages are sent. So however we are going to be transmitting in the circuit switching technique, here also we are going to be establishing the connection in between the sender and receiver. How we are going to be establishing the connection is, so I want to call request and call accept. So by using these packets, it is going to be establishing the connection in between the sender and receiver. So in this case, pre-planned route is established between the sender and receiver, and then going to be transmitting the data. And here through the call request and call accept packets are going to be used to establish the connection connection between the sender and receiver. In this approach, the path is fixed for the duration of the logical connection. So it is fixed for the logical connection only, for the duration, transmitting the data only. How it is going to be transmitting the data in the virtual circuit approaches, now I will show you. Yes, so here in this packet switching, what it is going to be doing, first it is going to be divides the data into the individual packets. The whole message is divided into the individual packets, and after that, so it is going to be establishing the connection. After that, it is going to be transmitting the individual packets 1 2 3 4. So the in the virtual circuit, it is the connection oriented, so it sends all the data one by one. And so it is the here the sequence number will follow it, one by one it is going to be getting and the data. So what the sequence number will help more in the datagram switching technique. How it I will show you now. Yes, so now we are going with the datagram approach. What is this datagram approach is, so in the datagram packet switching, it is also known as the connectionless switching. What it is the connectionless. The virtual circuit is the connection oriented, and it is the connectionless switching technique. Here, each independent packet is, so each independent packet is going to be called as the datagram. So what we are going to be, what is the datagram is, datagram which is similar to the telegram, and the olden days we have the telegram. So how the telegram, from that we have the word like datagram. Each individual packet is going to be called as the datagram. So this, all these datagrams having the information of the destination. So why? Because it is going to be sending individually, transmitting the data individually. That so it has all the destination information and the intermediary devices also. Why? Because to forward the datagrams in a right direction to reach the destination. And in datagram packet switching approach, the path is not fixed. However, in the virtual circuit approach, we are going to be fixing the path. But whereas in the datagram, it is not going to be fixing the path in between the sender and receiver. So, and the intermediate nodes will take the routing decisions how to forward the packets from sender to the receiver. So it is somewhat clumsy. So you get the clarity in the next slides. So what it is the connectionless switching. The each individual packet is going to be called as the datagram, and here all the datagrams are going to having the information of the destination information and the intermediate nodes. Why it is going to be having the intermediate nodes is to know the to know about how to transmit the data, how to route the data to in the right direction. Yes, here the path is not fixed, so on the network congestion it is going to be transmitting. So yes, how it is going to be transmitting in the datagram switching is, I will show you. So here this is the sender, and the whole message is divided as the 4 packets. These 4 packets are going to be called as the, these 4 packets are going to be called as the datagrams. So here it is going to be transmitting. Here in this datagram switching, it is not going, it is the path is not fixed, so each individual packet is transmitted independently. How it is, yes, here the packet 1 is going to be choosing in this way. So the packet 1, the datagram 1 wants to travel in this path to reach the receiver. The second packet wants to, second packet wants to go in this manner. So and the third packet, so again it comes reach to the this router, and so which path is clear, so the router will decide the route and which path it wants to transmit the data. So like that 4 also. So you know, in this way it is going to be routes the datagrams in the various ways. So here the receiver receives all the packets. After some time it receives all the packets are reached at the receiver. Here the order of 1, 2, 4 and 3. The third packet is reached, so after the 4. So the receiver will reorder the data with the help of the sequence number. Again the receiver will reorder its the datagrams. So again it reordered 1, 2, 3. 4. So in this way, the receiver will receives the data in a various switching techniques. So due to this, what we know from this class is what is switching. Switching means deciding the path from the multiple paths. So how we are going to be implementing in the networking is in the three ways. What are the three ways? The circuit switching, message switching and packet switching. So and the packet switching we are going to be implementing in the two approaches. So one is virtual circuit approach and the datagram approach. So in the next class we'll continue. Thank you. If you have any doubts, please raise. Thank you.